Hi there, and here's the next video on finding angles in shapes, part 3. This one's to do with angles in parallel lines, and this one's a pretty long and a little bit more of a heavy one, and it's a very important one, so definitely listen up, take your time and make sure that you understand what's going on, and maybe read over your notes after you've taken them as well, so they go more so into your long-term memory. So angles in parallel lines. So what are parallel lines? So remember, you might have watched the song already by Colin Dodds. Remember, parallel lines, they remain the same distance apart from each other. So in the song, as he said, it's as if they don't like each other much. They keep remaining the same distance away from each other. So parallel lines, what's the name of the line that crosses the parallel lines? Remember, it starts with T. So a line that crosses a pair of parallel lines is called it was in the song as well. That's right, it's a transversal. So this red line here is called a transversal. These are the parallel lines. These are the little arrows to indicate that they're parallel. So the blue lines are parallel lines, the red line is the transversal. So it's a line, and when you put a transversal, when you draw a transversal across a pair of parallel lines, it generates all these different angle relationships. For example, that's the same as that, that's the same as that, this one's the same as that one, this one's the same as that one, these two are to 180, these two are to 180, and so on. And so there's special names for those types of relationships, and that's what you're going to be learning in this video. One that you probably know already, and that he mentioned in the beginning of the chorus, was vertically opposite angles. And what did he say about vertically opposite angles? That's right, he said they're equal. So vertically opposite angles are the angles made by intersecting lines. So you've got intersecting line here, you've got intersecting lines here, you've got intersecting lines here. Vertically opposite angles are equal in size. In the diagram, angle 2 and 4 are vertically opposite. They're the same size as each other and they're both acute. These 1 and 3 are vertically opposite. They're the same size as each other. But 2 and 3 are not vertically opposite. Instead, they add to 180. So sometimes people call them vertical angles, sometimes people call them vertical opposite angles. I call them vertically opposite angles. So therefore, that's the terminology I'll be using. So list the pairs of vertically opposite angles that you can see in the diagram above. So what pairs can you see? Let's see, there's this one and this one, there's this one and this one, there's also this one and this one, and there's this one and this one. So maybe let's write those ones out. Oops. There you go. Okay, so we've got E and G, so let's colour code those maybe to point out E and G, we'll do those in blue. So we've got E and G are equal in size, and they're vertically opposite each other. That's the reason why they're equal in size. F and H, let's colour code those with green or whatever colour you want, different colour. So those F and H are vertically opposite and they're equal because they're vertically opposite. B and D are vertically opposite and they're equal in size. And also A and C are vertically opposite and equal in size. So we've colour coded those angles. So that's called vertically opposite angles, and that's something you might have known about already. But you probably haven't seen it in the context of parallel lines. That's what's probably new to you. In fact, before you just saw it in terms of ones like this, now you're seeing it in terms of parallel lines, and a transversal generates 4 pairs of vertically opposite angles that are equal in size to each other. So from your own research, you might have done some research, you could Google it now if you want. You can pause and Google what are adjacent angles. So feel free to pause the video, Google yourself what is an adjacent angle. So, and when you unpause that, you'll probably realise that adjacent angles are kind of like angles on a straight line, so it's quite familiar to something. Adjacent angles are side by side on a straight line and add up to 180 degrees. So, for example, these two are adjacent. So beforehand, we would just say that they're angles on a straight line. But now when we're talking about parallel lines, we also can have a special term that we call adjacent. Adjacent means right next to each other. So these two are right next to each other, whereas these two are vertically opposite. Adjacent angles, notice that they don't add up, they're not the same as each other. For example, B is obtuse, A is acute, but they add to 180. Here's a pair of adjacent angles, here's some adjacent, here's some adjacent, here's some adjacent. So how many pairs of adjacent angles are there when two parallel lines are cut across by a transversal? Have a think. There are actually 8 pairs. 8 pairs of adjacent angles. So for example, we have A and B. A and B adds up to 180 degrees. So if you want, we can colour code them if you want. So they're not equal, but they add to 180, A and B. We also have F and E, adds 180 degrees. The common mistake is some people might think they're equal, but they're not. They add to 180. C and D, we also have. And we have A and D. So we have A and D as well. We have C and B. C and B. G and H. F and G. We have E and H. So 8 pairs of adjacent angles. Don't forget, adjacent angles are side by side and add up to 180. So remember, keep reviewing as you go. So beforehand we noticed that we revised that vertically opposite angles are equal in size, and that these parallel lines and that line that crosses the two pair of parallel lines is called a transversal. Also, we've just learnt that adjacent angles add up to 180 degrees, and there's 8 pairs of adjacent angles when you cross a pair of parallel lines with a transversal. So there's some more angle relationships though. So what are some of the other ones? Corresponding angles. So here's an example of corresponding angles. So what do you think the relationship is between these two just by looking at it? That's right, they are the same size. So they don't add to 180, but they're the same size. How would you describe what corresponding angles are? So one way you could say is corresponding angles, they're on the same side of the transversal as each other, and they're in a similar position relative to the parallel lines. So these are on to the left of the transversal, and they're both below the parallel lines. You could have also had to the left, to the right of the transversal and below the parallel lines, like this one equals that one. You could have also had to the left of the transversal and above the parallel line, so this one here equals that one there. You could have had to the right of the transversal and above the parallel lines, that one there equals that one there. So some people call this a fangle, to see how it makes kind of like an F shape. So list the pairs of corresponding angles you can see in the diagram below. So for example, this one, C and G, what's another pair? That's right, we have D and H. What's another pair? We have B and F. See, they're both to the left of the transversal and above the parallel line. Plus we also have A and, what's this, E? It's because they're to the right of the transversal and above the parallel line. Maybe let's colour code some of those angle relationships. Corresponding angles are equal. So remember in the sum, vertically opposite angles are equal, corresponding angles are equal. So C and G are equal, D and F, H and D, and A and E. So by a fangle, don't ever use the word fangle as a justification, is notice that, say for example, the blue ones, D and H, they form this kind of F shape. Or it could be an upside down F. Or it could be a back to front F, for example. So that's why I tend to call them a fangle as a nickname. But don't call them that officially, they're corresponding angles. Great. So that's corresponding angles. So we've done vertically opposite angles, we've done alternate angles, add to 180, vertically opposite angles are equal, and corresponding angles are equal. Now we're about to do alternate interior angles. So like in the song, he said alternate interior angles are equal in size. So what's some examples of some alternate interior angles? We've got this one here and this one here. So alternate, see they form these, I call them Z angles, because see they form these Z shapes. So we've got these Z shape here, so that little one is equal to that one, plus a bit of a weird looking Z shape. So that one there equals that one there. And they're called interior angles, alternate interior angles, because they're inside the parallel lines. So they're on opposite sides of the transversal, So you could say are on opposite side, they're alternate interior angles because they're alternate because they're on opposite sides of the transversal, and interior because they're inside the parallel line. So that's why in the song they call them alternate interior angles. So they're equal in size. So vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal. So they form these Z shapes. So let's list a pair of alternate angles that you can see in the diagram below. So remember they have to be inside the parallel lines and they have to be on opposite sides of the transversal. So all we've got is D and F and C and E. We can't have any that are outside the parallel lines because it's alternate interior angles. So all we have is C and E plus D and F. That's all we have. So they form these Z shapes. So Zangle is my nickname for that. But again, just don't call them Zangles, call them either alternate angles or alternate interior angles. So in the song, there was only one more because I said vertically opposite angles are equal, corresponding angles are equal, such as these ones, and then alternate interior angles are equal. How did the chorus end? That's right, they said co-interior angles equal 180. So the next page you'll see co-interior angles equal 180, meaning they add up to 180. So what are co-interior angles? Notice that they're not equal in size because one's obtuse and one's acute. They're on the same side of the transversal and they're inside the parallel lines. So not equal in size necessarily. So more so they add up to 180. Oops. So list the pairs of co-interior angles that you see on the diagram below. So they have to be inside the parallel line. So not these two because these two are alternate interior and they're equal. Co-interior are on the same side of the transversal and inside the parallel lines. So D and E add up to 180 and C and F add up to 180 because it makes sense. One's acute, one obtuse, so they can't be equal. So we've got D and E add to 180. Here they are, add to 180, plus also F and C add to 180. So they're co-interior, so interior meaning they're inside the parallel lines. So remembering, we're going to do a little wrap up now by just doing a little bit of a mixed problem. Find the angles marked with the letters and give reasoning. Oh, they disappeared for some reason. Just 1 second. Okay, fix that problem now. So find the angles marked with the letters and give reasoning. So the reasoning could be like vertically opposite angles are equal, corresponding angles are equal, alternate interior angles are equal, and co-interior equal 180. One thing the song didn't mention was adjacent angles. Adjacent angles, remember, are side by side and add up to 180. So they've said angle A is 30 degrees. So maybe let's go around in this order. Let's go down in this order to work out B. How could you work out what B is from if you know that A is 30 degrees? And what rule could you use? So that's right, they are adjacent angles. So angles on a straight line is one way of reasoning, and also you can say now adjacent angles. Adjacent means right next to, and they add up to 180. So B must equal 180 minus 30, which is 150 degrees. So adjacent angles add up to 180. Then if you know that that one is 150, how could you work out C? There's so many different ways you could work out C. You could have these vertically opposite angles are equal, or you could use adjacent angles. So I'm going to use the easiest one. 30 degrees, go straight to saying it's 30 degrees because vertically opposite angles are equal. I personally find that easier. And now we know this one, and this one. We can work out D using adjacent angles, or we could use vertically opposite angles. So I'm going to use vertically opposite because that means I don't have to calculate anything if I do that. So that makes my life a lot easier. So 150 degrees because they're vertically opposite to B. So at this point it might be easier to write it in. So because to work out these ones we might need to be aware of what the ones above are. 150 degrees We know this one's 30 degrees, 30 degrees, and we know the other one's 150. So filling them in as you go can help, because now you might not be aware that you can work out the ones at the bottom because you forgot you worked out the ones at the top. Okay, so E, let's go down to the next one. E, lots of different ways you can get E. You can use the fact that they're alternate. So alternate interior angles are equal, so E and C are equal. You could also use the fact that E and A are corresponding, and corresponding angles are equal, because that forms that fangle, whereas the C and the E form the zangle. You could also use co-interior equal 180. So which one did I use? You can use any one of those, which takes your fancy. 30 degrees I did corresponding with A. So E is 30 degrees because it's corresponding with A. So E is 30. Maybe I'm going to fill that in now. Corresponding angles are equal. So remember, corresponding angles are on the same side of the transversal and in the same position relative to the parallel line. So they're both to the right of the transversal, the red one and the black one, and they're above the parallel lines. So F, lots of ways you can work out F. You can use corresponding with B. You can use that's alternate with D. You can use that it's co-interior with C, or you can use that it's adjacent to E. You can use any one of those that you like. Which one did I use? I used 150 alternate with D. So 150 degrees because it forms a zangle. So it's alternate with D is the one I happen to use. Okay, and then G. So I'll fill this one in just to prove that you can use lots of ones to get G. So 150 degrees. Notice I'm colour coding. See how I'm giving my reasoning? You must write your reasoning too. So that's very important. Make sure you write your reasoning because you've got to get familiar with these terms, and we'll ask you to give reasoning. So you must do that. Same thing in your GCSE exams. They will often ask you to give the reasoning, and you've got to use these words: adjacent, angles, vertically opposite, corresponding, alternate, and so on. Okay, so now we're up to G. G, you could say that it's vertically opposite E. That's probably the easiest one. You could also use that it's adjacent to F. So it adds up to 180. You can also use that it's corresponding with C, so they're equal to that, and so on. You couldn't use alternate because it's not interior. Alternate interior and co-interior have to be between the angles inside the parallel lines. So what did I happen to use? I used 30 degrees because it's vertically opposite with E, because I personally found that one pretty easy. Vertically opposite, easy to see, easy to write, easy to remember. 30 degrees, and H, the last one, you can use almost anything. You can use that it's adjacent to E. You can use that it's adjacent to G. So they add up to 180. You can use that it's vertically opposite F, so equal. You can use that it's corresponding with D. And they're the only ones you can use because you can't use alternate interior because that's only for inside the parallel lines. And you can't use co-interior because it's not inside the parallel lines. So what did I use? I just thought I'll mix it up a bit. It would have been really easy to just say vertically opposite, but I thought I'll mix it up and practice my other one that I haven't used much, which is adjacent. I only used adjacent once up here. I didn't really use co-interior either. So you might want to write an example of a co-interior one. For example, E is co-interior with D, so that might be a good one to do. So H equals, I said that it's adjacent to G. So these two add up to 180. So H must be 180 minus 30, which is 150 degrees. So don't forget, you must record your reasoning. You should be recording your reasoning as you go. Just showing you an example. See how, like when I did my ones, I wrote down the working out and I gave the reasoning. So make sure you're doing that as well when you're doing your problems. Okay, thank you very much.